Okay, I will use this demo to demonstrate how to use a simulation to run my program. And what I need to do is to run the launch file, and that is the control panel, and all following instructions will finish at that panel. I have integrated all the functions and models. So here we can input the world parameters and now support 3 different maps. And in default, it is a bookstore. So let's see it. When I launch this launch file, there will be many controller windows and run here. These are for developers, and each window represents a ROS node that is a controller to control, to print the ROS log and to tell the developer what happened in that node. And for user, what he needs to know is how to use this control panel. And this is the window that can make all decisions and to do all the instructions, follow all instructions. So now this map is a bookstore and it is provided by the Amazon AWS. And the robot is the Turtlebot 3. And we have also built a real model of this Turtlebot 3. And in the real demo, we will represent that. And in this control panel, we can use a robot control to control the robot to move, like to turn left, turn right, and in the middle, this means the stop. And here we have 4 models. The first one is the mapping function, which is to explore the room and build a map. The second is route analyze, which is used the map built by the mapping function and to analyze the route. You don't need to finish all the map. It can build the map based on the area you have explored. And the cleaning function is to follow that route, allow the robot to clean every part. And the voice recognition is always running and hear what you have said. And you can use the voice command to control the robot. And I will show it later. The run hint and instructions will tell you what happened if you use some button or speak some voice command and give the instructions for the users. The last part is ROS log output for developers. This is just like the these terms that it is provided for developers, which is me, and to find the bug and know how to debug. And now I will show the first function, mapping functions. So first of all, the user need to start this lab, which is provided by the ROS and Turtlebot 3, which can build the map in real time. And the map is stored in the memory. And now you can see the map. There is nothing in the map, so we need to explore the environment. And we can use this button, or we can just use the voice command like start exploration. So here you can see that the start exploration has been recognized and the robot will start exploration. And this exploration model is provided by the Explore Lite package. And the robot will use frontier exploration algorithm to explore every part of the room automatically. And the user can stop this process if he thinks the map is enough for cleaning, or the robot will continue exploration. And in later version, we will introduce update like set a time to explore or to determine whether the exploration is enough. So let's wait for about 10 seconds. Remember, we don't need to explore all parts to clean, to start clean. So we can only allow the robot like explore some part of the room, and we think it's enough for the robot to clean. Then we can analyze the route and make the clean. So when the robot exploration, we can always stop it. And if you think the exploration is not ideal and want to use your own hand to explore, you can use this robot control to move the robot to somewhere and to allow it explore. And you can always stop control by yourself and restart exploration. So every time you start exploration, it needs like several seconds to consider where to go. And let's wait about 10 seconds to make the map larger to demonstrate the following instructions. Okay, I think it is enough now. So I can just say stop exploration. You can see that it was recognized, so the robot just stopped. And now we can click Save Map. Okay, the map has saved. We can open this file folder, which is here. And we can see the map is saved here. Compare it. Cool. So when the map is saved, we can finish mapping. What's next? Since we have a map, we can analyze the route, right? So we can firstly load map. RVs again. What's different? In the first function module, in the mapping module, it uses SLAM, SLAM to build the map. And now it is another technique which is called AMCL, which is to use that map to consider where is the robot. And we can see many red arrows. So it will be considered to find the position of the robot and we can control the robot to see, because the map is not built, it's not finished. So let's see if the robot is in the right place. Oh, it's not. I think it is 2 bookshelves, and we can move it because the map is not built finished. So we can move it here. It is, I think it's nearly to the real position, and okay. And we can control it to move. We can see that the arrows, red arrows, are dramatically decrease, which means the estimate of the position will be more precise. So this is the technique of AMCL. And now we have loaded the map successfully, and we can analyze that. So the analyze algorithm is to use that map. And I will click this analyze. Now it is analyzed. What happened? So here we have a map before, right? I will open it. And the analyze program will use this map to find the route. It's here. So firstly, the program, the algorithm is to find the possible accessible areas. Since this map is not built in and there are many unsure areas, so these all areas will be recognized as unaccessible areas, which is black point. And these two maps are totally same, so it's just in different directions. And after this, the map will only remain the white part and black part, which means the accessible area and unaccessible areas. So the next step is to find the root. So the root is based on the red points, which means the root marker. And we firstly draw root markers as red points, and then use greedy algorithm to find the unoptimizable possible root and connect all the points together. So we can see this process in RViz. You can just need to click show root, and that root will publish that path connections and path visualization topics. We need to wait for about several seconds to let it process these informations, because when the map is bigger and bigger, these red points are enormous. For example, if the map is built for this bookstore, there will be like 3,000 red points to show. Okay, so now we can see that there are many points on the map. Here, black points means these are the root marker, represent that this point is inaccessible. And the red point means it is accessible. And the root will analyze based on accessible areas. And you can see the blue arrow. And here there is a direction for each red point. And after this, we have finished the steps of root. Next, we can use cleaning module. So we can start cleaning. And we need to change this topic to the status visualization, which will have, instead of a black and red point, it will introduce a new point, which is gray. And here is the cleaning logic. When the robot finds a red point, the robot will reach that red point and follow the route, which is blue, to next red point. If the robot reach that red point and clean that area, the red point will change into green point, which means that area was cleaned. After that, the robot will continue following the route. And if there is a red point in the route, but the robot cannot reach that point, for example, if there is an obstacle, that might be a moving obstacle, then the robot will mark that point as black again. And the robot will find another, which is the nearest red point, to reach that point. So this is the basic logic of cleaning route. So you can see that the robot is finding each red point on the route and to follow that route. If something happened to make the robot miss that route, miss that point, the robot will back to that point again to make sure the point is clean. And this function is just okay. So it finds that there might be an obstacle, so the robot find this point is unreachable. So the robot will find another red point to continue sweeping, continue cleaning. So this part has more situations we need to consider and to update since it is the latest version. But we have now achieved the foundational functions of cleaning, that the robot can build a map, to load that map, analyze a route, and follow that route. Though it is not very smart now, but we have achieved the foundational goals. So this is the demonstration here, and we can you can see that the robot is cleaning on the way it should be. So the next step is to update the route following program to make the follow more like smooth. And why we write these functions our own instead of use move base, because I think this is the core function of this cleaning robot. So we need to write it on our own because the exploration is not the core part of this cleaning robot. But the cleaning must be the most essential part because it is cleaning robot. So the cleaning model must be highly DIY. You know what I'm saying? So this is the V2 version. And in next 2 weeks, we will update to version 3, which will be more adaptable with different atmospheres and will follow the route more smooth. And also the map building function will be updated. And after version 3, I think the exploration module might be modified by our own and write a more DIY function of exploration. So you can see that the green route is basically follow that route. And we can stop cleaning and quit program. So it might be some time to close the gazebo. And this is it. Thank you.